let's learn how to find weighted mean. We find weighted mean value anytime our data values, namely x1, x2, x3, and so on, up to xn, come with corresponding weights. So weights W1, W2, W3, and etc. up to the last weight corresponding to x of n, Wn. And so once again, these symbols W right here, they are referred to as the weights. And so anytime each data value comes with a weight correspondingly, then generally speaking, the formula to find a weighted mean is symbolically, we're still going to use the lowercase x bar symbol, and the weighted mean is given in the following formula. x1, the first data value in our list, multiplied with corresponding W1 plus x2 multiplied with W2 plus x3 multiplied with W3, the corresponding weight, and keep adding, etc., to the last value xn multiplied with the last weight Wn. And the same fundamental about finding average. Anytime we're finding an average value or a mean value, we need to divide by a total. But in the special, in case when we're looking for a weighted mean, then that total is the total of all weights. So here in the denominator, we are for finding a weighted mean, we are actually going to divide by the total of all weights. So weights W1 plus W2 plus W3 plus, keep adding until we reach to the last weight. So I have to really emphasize that when we are finding weighted means, each value is to be multiplied with its corresponding weights, add up all the pairwise products between value and weights, and then we divide by the total of all weights in the denominator. And that is our general formula for finding any weighted mean. And in some special case, and in a special case where, so let me now indicate that what we have here is what I'm about to say here is a special case. Our special case is that if those weights W1, W2, all the way up to Wn, or in percentages, so anytime that our weights here are being expressed in percentages, then keep in mind one thing, that the first understanding is that expectedly those weights W1, W2, and W3, and so on, will total up to be a 100%. And in decimal equals 1. And so in that case, that's consequently produce a special formula for us. So when our weights are in percentages, then the weighted mean formula has the special formula x1 times W1 plus x2 times W2 plus x3 times W3 plus so on to xn Wn. And the denominator, which is the total of all these weights together, is supposedly 100% or 1. So here we can skip the denominator because it's 1. But keep in mind, this formula is only used when these weights are in percentages. And I need to make also an additional note here. These weights need to be in percentages. And further, W1, W2, Wn are in decimals. We're expressing those in decimals. They're coming out from percentages, but we're writing them as decimals. Then these weights in the denominator will equals 1. So we consequently have a shorter, more convenient formula. Mean value, weighted mean x bar equals x1 times weight 1, x2 times weight 2 added, plus x3 times weight 3 plus, so on and so on, up to xn times weight n. And let's now apply what we have just learned in terms of finding the weighted means into doing an example. So let's look over at my computer screen here. Let's have a moment to read the problem, and feel free to pause the video anytime you feel comfortable to read the problem. But so in a college class, your final grade is based on 4 components: overall homework score, overall quiz score, overall exam score, and your score on the final exam. So there are 100 points available for each score here. The overall homework score is worth 31%. So this statement here indicates that our homework of this class, so homework as one component, or sometimes I also use the term category. So homework as one category, as one component, weights 31%. Then the next statement here in our example says overall quiz score is worth 10%. So all quizzes, you might have 10 quizzes, you might have only 8 quizzes, but all quizzes together weight 10%. And so these are the weights correspondingly. And then next, our statements here in the example say exam score is worth 40%. So all exams, you could be having only 1 exam, you could be having 3 exams, you could be having only 2 exams. It all depends on your instructor. But in the end, all exams together is worth or weight at 40% of your final grade. And the final exam weight at 19%. And then so the idea about these weights here, you can also double check quickly that all these weights here will total up being the total of all these weights. We can quickly see that it's 100%. And so that's the weights. So what to keep in mind about these weights is that once they are given out, or once they are decided from the instructor, by the instructor of the course, of the class, then it stays the same for everyone in the class. So you are in that class, you have the same weight distribution. Somebody else is taking the exact same class with you, they take the exact same weight distribution as yours as well. What matters is how you earn the score on each of these components. That will make your average difference with anybody else in class. And so this is the data that's supposed to be your own performance right here. So the data reflects the following, and I have to make a note. This is your own performance. So on the homework, you have earned, after all homework, you have earned 90. And so the statement in the question, in the example, says there are 100 points available for each score. Basically, it just tells you that any of these data value can also be measured in terms of the percentages. So your homework, you have earned 90%. You have completed 90% of all your homework. The quizzes, on the quizzes as a separate component, as a separate category, you have only completed, so all that information I've been extracting out comes from here. And so 25% on the quizzes. So here we're looking at 25% on the quizzes and exams. Let's say in this scenario over here we have only made 26% on all exams. And on the final exam we have made, or you have made 37%. And so these are data, and this is particularly your data, and keep in mind that anybody else in class can have a different data distribution, but they will have the same weight. And so now to find a weighted mean, in this case right here, we have different values. We have values, and each value in our data comes with a corresponding weight. And so our weighted mean comes as following. 90% is the actual score in our data. We are multiplying that with 31%, but I said earlier, express that in a decimal. So 90 as a percentage, that's your actual data, but we multiply with 0.31. The next data value in your data, in your own performance, is 25%, and that percentage multiplies with the weight being 10% in decimal, which is only 0.1. Plus, and the next data value in your performance is 26% on the exams, and we multiply that with 0.4 as for all exams weight, 40% of the final grade. Plus, and the last piece of data we have here is 37% that comes out from your final exam. We are multiplying that with weight, 0.19. And so there is no need to divide by the total of all weight, even though we are supposed to divide by the total of all weight. But in this case, since the total of all weight is 100%, and which is 1, so we're just gonna skip dividing. Final calculation in this case comes out to be 47.83%. And that is how we are calculating the value of a weighted mean.